All right, today we're going to talk about rewriting equations and formulas, or literal equations, as they're referred to quite often. And literal equations just means that really what you're doing is you are solving an equation for a specific variable, and you generally have more than one variable in there. So, for instance, in 5y plus x, it's saying solve for y. What I'm going to do is I'm going to move everything away from the y. So in this case, I'm going to draw my line, and I want to move the x and I want to move the 5 away from the y, so that I'm just left at the very end with y equals, and then everything else on the other side. So really you think of the other side, your right side in this case, as like a collection place for all your for everything other than y. So in this case, since the x is attached through addition, we're just going to do the opposite, and we're going to subtract that x. Just like if it was a 6, like let's say that was a 6 here, we would subtract 6 on both sides. But it's not, it's x, so we're going to subtract x. That's going to leave us with 5y equals 35 minus x. Okay, and then I'm going to go ahead and, since the 5 is attached to the y by multiplication, I'm going to divide both sides by 5. And really, when I say both sides, I'm dividing every term by 5. So since the 35 and the x are separated by a subtraction symbol, you're going to go ahead and divide both pieces by 5. So in this case, 5 divided by 5 is 1, y. 35 divided by 5 is 7. And x divided by 5 is x over 5. Okay, and so the other way to write that is actually to move the x over 5 out in front. So since it's a negative x over 5, we can write it as negative x over 5. And this is a positive 7 out. We read it like we're reading a book from left to right. So since there's not a symbol in front of 7, it's a positive 7. So when we rewrite it, it would be plus 7. And this is a negative x over 5, so we'd rewrite it as being negative x over 5. And then the other way to think about that, that's like a negative 1 x over 5. So you could write that as negative 1/5 x plus 7. And the only reason I show it on that one is because really later this year, when you're dealing with these, you're going to a lot of times be going from either standard form to slope-intercept form, or you're going to be solving for a y a lot, where you're getting y by itself. And it's nice. This is slope-intercept form when we get to that, so you'll be wanting to be able to see that. Okay, and so here, solving for y, notice it's always good to try to simplify both sides of the equation first. So in this case, I can actually put the y's together. 5y minus 4y is 1y. And in this case, 1y equals x. You solve for y, and in fact, you also solve for x at the same time. You're now done. Nothing else to do there. But there are times when you can't put the like terms together. So ay and 4y, they can't put them together. So in that case, since there's y in both of them, what you're going to do is you're going to undo the distributive property. So think we've done to the distributive property a lot so far. Okay, we're going to undo it. All right, so I'm not going to change this side yet. It's still going to be x. But on the left side, I want to take out the thing that both of these terms, this term and this term, have in common. They both have a y in common. So I'm going to undo that. I'm going to pull that out of there. And then I have y times what is a y times a. And y times what is positive 4, and that would be positive 4y, that would be positive 4. And so really I'm just taking this y and this y and bringing them outside here, and then I have the a plus 4 inside. So notice that if I were to multiply it in, it would be ay and 4y, which I have up here. And so from here I now have a situation where this is multiplication. I'm multiplying y by this entire chunk right here. So if I were to just kind of pretend I don't know what's in this, I have y times something. So to get rid of that something and to be left with y, since it's multiplying, I'd have to divide by that something. Okay? And I divide this side by that something. All right? Well, that something, to be more specific, we'll kind of get rid of that. That something here, oops, I erased part of my number there. That something is a plus 4, so I'm going to divide by a plus 4. And I'm doing that because it's in parentheses and it's attached to the y through multiplication. So that breaks it apart. Whenever it's attached through multiplication, you divide by it, just like we did over here with the 5. It was attached with multiplication, so we divided by it. The x wasn't. The x was attached through addition or subtraction, so we add or subtract. Okay? And so in this case, a divided by 4, or a plus 4 divided by a plus 4 is 1. So that's 1y. They just cancel. And x over a plus 4, you could just write like that. You don't have to put the parentheses. Let's fix that. A looks like a 9. But you don't have to put the parentheses because really there's implied parentheses in the denominator. They're implied that they're there. So you're done. So that by the way, undoing the distributive property, this is called factoring. And you probably hit that last year a bit. It's called factoring. But it's really just undoing the distributive property. Okay, but we'll reference it as factoring later. So same thing here. I want to get y by itself. I look at this and I go, well, there's a y and there's a y. This doesn't have a y. So I could get rid of this by subtracting 3 on both sides. Now what ends up happening is I kind of get this this kind of holding place of numbers and variables here. So I have x minus 3. I can't put them together, so I just write it as x minus 3. That gives me 0, and I'm left with negative ky plus 2y. And here I have a y attached through multiplication in both of these. So once again, since there's a y and a y, I can undo the distributive property. I can take that y out. Y times negative k is negative ky. And y times positive 2 is 2y. So if I were to distribute it, and I get that same thing, I've undone the distributive property, or, once again, it's called factoring. And now, since this is attached through multiplication, I'm going to divide by this whole piece. I'm going to divide by negative k plus 2. And negative k plus 2. Kind of running out of room, so I'm going to make my line kind of go out like so. Okay, and so here, x minus 3 over negative k plus 2 is equal to, well, this one cancels that one. That's equal to y. All right, and got y by itself. We are done. All right, so those are kind of the difficult ones. If I were to move on, we also deal with a bunch of formulas. So I have 4 formulas here. Perimeter equals 2L plus 2W. That's perimeter of a rectangle. You know, if I'm solving for L, you'll notice here there's 2L and 2Ws. I could, this semicolon L, that just means, this part just means solve for L. So it has nothing to do with the equation. It's just, hey, we're going to solve for L here. So in other words, we need to get L by itself. Okay? And so one way to do it, we can move that 2W over. Okay? And so I get P minus 2Ws equals 2Ls. And then get rid of that 2 that's attached through multiplication by dividing. So really, when you have formulas that we have here, you really just have more variables you're dealing with. And maybe something that looks somewhat familiar. Oops. Something that looks somewhat familiar too. Yeah. Okay. And by the way, a lot of times you'll see L written like that, a cursive L. I didn't do it there, but you could have just made that a cursive L and that a cursive L. Okay. So area equals 1/2 base times height. Solve for height. I'm going to go ahead and I'm going to get rid of this fraction of 1/2. Anytime I have a fraction, just multiply by the denominator. That'll just get rid of the fraction, and then you don't have to worry about it. So if I do this on here, I'm going to rewrite this. So 1/2 BH without that extra h there. I'm going to just multiply everything by 2, the common denominator. Okay, and 1/2 times that times 2. Well, 1/2 times 2 is 1. So really a 1/2 and a 2 cancel out, so I'm left with BH. B times H equals 2A. And that makes it a lot easier. Now if I'm solving for H, attached through multiplication, I just divide by B. B's cancel. H is equal to 2A over B. Okay, make sure it looks like a B and not a 6. All right. Area equals pi r squared. Solve for r. In this case, a couple things. We have a pi, and we know pi is like 3.14, blah, blah, blah. But we're going to treat it almost like, we're going to leave it in its pi form, almost like a variable. So we're going to go ahead, if I rewrite this as a equals pi r squared again, and solve for r, I'm going to go ahead and just divide out that pi because they're multiplying by it. And so that's the opposite. We divide by pi, we're left with now just the r squared. And really, if I want to get r by itself, I have to get rid of the squared. Well, the opposite of squaring something is to take the square root. So I'm going to call it the square root. Okay, if I put that square root in there, that's going to cancel that. Okay, and so when I do that, I end up with taking the square root of this side as well. And that means r is equal to the square root of a over pi. Now you're going to learn later in the year when you impose a square root or you put a square root on, you have to do a positive negative out in front, but that's not going to apply in this problem because you're talking about a distance for radius. So we're just going to leave it like that. The opposite of, hey, we're going to go on to this next one, s equals pi r squared plus pi r l, and we're going to solve for l. Now I had solve for r, but that's a much more complex problem, so I changed it to solve for l. That kind of gets us into a little more of the practice I wanted to see. So what we're going to do is we're going to first, well, first let me go ahead and rewrite the equation. So we have the extra L that we're solving for out of it. Okay, and so notice we have R in both of these. So in this case, since we're not actually trying to solve for R, we can just take and get rid of this piece first. Okay, so sometimes when we get in the habit of just factoring or undoing distributive properties, say like we had to do on some of our previous problems, we start going, oh, well, there's R in both, so I'm going to factor it out. Well, that's not the case here because we're not solving for R. We're solving for L. So we're going to take away the pi r squared since it doesn't have an L in it. And that just moves that whole chunk over. It's being added to this, so we'll take that away on both sides. We get S equal, or S minus, excuse me. Oops. All right. Minus pi r squared equals now pi r l. And so since I really want to solve for L, this whole chunk's being multiplied by it. So I'm just going to divide by pi r l. Or excuse me, divide by pi r, the piece I want to get rid of. I can divide by two things at once since they're both being multiplied. And that leaves me with S minus pi r squared over pi r equals L. And we're going to leave it like that. That way we're not canceling out some r squareds and giving it a much more complex look. And this pi, we're going to just leave the whole thing as S minus pi r squared over pi r. And that is equal to L. All right. So you'll notice that some of the formulas get kind of ugly, but it allows us to, by doing this with formulas, it allows us to know certain things. Like this is surface area of a cone here. And so if I know the radius and the slant height, I can find the surface area. Well, this formula, when we transform it, this says if I know the surface area and the radius, I can find the slant height. And if we were to solve for r, if we knew the surface area and the slant height, we could find the radius. Just like this, a equals pi r squared, area of a circle. Well, in its original form, area is equal to pi r squared. If I know the radius, I can find the area of a circle. Well, when I transform it, if I know the area, in this one, I can find the radius. Just makes it a little easier to do. Okay, so let's go ahead and move on here. Some formulas, Celsius and Fahrenheit. This is a formula, you'll see this section. Celsius equals 5/9 F minus 32. You know, if you ever know the Fahrenheit temperature and you want to find the Celsius temperature, really I use a lot of estimation. If I know the Fahrenheit temperature, what I try to do, a quick estimate, for instance here, it's Fahrenheit, or it's 59 degrees Fahrenheit outside, and I want to know what that is in terms of Celsius. A real quick estimate is to just take whatever the Fahrenheit is and subtract 32. And then multiply it by 5/9. Now, the 59 minus 32 is not all that complex. I mean, that would give you like 27. 5/9 is a little more complex, okay? Because if I can do that, I automatically know the Celsius. Well, 5/9 is a bit more complex, but I like to think of it as 5/9 is really close to 1/2. Like if this said 4.5 over 9, that would be 1/2. Well, 5 is pretty close to 4.5. So half of 27 is about, half of 27 is 13.5. So really, Celsius is approximately 13.5. Now that's my quick estimate. Now if I actually did the math, this is an easy one. We cross cancel. That becomes 1. That becomes 3. And that's 15. Okay, so we were pretty close. Celsius is 15. Our estimate was 13.5. Okay, that pretty close. All right, so we can always estimate. If it's 20 degrees Celsius outside, what temperature would it be in Fahrenheit? Really, what you could do is you could take your Celsius equals 5/9 of F minus 32, and reality is most people, unless you're doing some kind of program or something, most people will just plug in what you know and do some math and get out the answer. But in this case, 20 degrees Celsius. Let's say since you're looking for Fahrenheit, maybe you want to solve this equation right here, this formula for Fahrenheit first. So I could, since I'm multiplying by 5/9, I could go ahead and multiply both sides by the reciprocal. I quite honestly think this is, I think this is a bit more intense than we really need to get into, but it's application of what we're learning. So 9/5 here. And so I'd have 9/5 times C is equal to, well, 9/5, the reciprocal cross cancels. And so now I'm left with F minus 32. And so we'll add 32 to both sides. And so you get, let me write it over here. We'd end up with 9/5 C plus 32 is equal to, that cancels with F. And so really what this is saying, if you know the Celsius, you can multiply it by 9/5. Well, 9/5 is really close to 2, right? 10/5 would be 2. So a quick estimate would be double your Celsius and add 32 to find the Fahrenheit. So like if it's 20 degrees Celsius, I could double that, that's 40, and add 32, that's 72. My quick estimate would be 72 degrees Fahrenheit. Well, if I actually did the math, 9/5 times, I'll put the 20 in for Celsius and add 32. The actual math here gives me 9/5 of 20. Okay, that becomes 36 plus 32. So the Fahrenheit is 36 and 32, or 78 degrees. Okay. So, or not 78, excuse me. I got hung up on the 78 there. 68 degrees. All right. So 68 degrees Fahrenheit. And so we're pretty close with 72. But yeah, if you're doing a quick estimate, that's not too bad. All right, the next one is interest equals principal times rate times time. This is simple interest. Really it's saying, hey, if I want to know how much money I earn in simple interest, I am going to take my P, which is principal, which is how much you invest or how much you have to begin with. It's your starting amount. Okay, and you're going to multiply it by your rate. Your rate is in terms of decimal, like decimal form. Usually you see a rate in a percent. Okay, we want to change it to decimal. And then times time, which in years there. And so we have I equals PRT. Okay, and so in this problem, interest, you borrow $10,000 from a bank at 8% interest, or 8% rate for 5 years. Well, $10,000 is the amount you borrow. That's your principal. Your rate is 8%, and what I tell students to do is to think of it in terms of money. Like if we say 8%, that's like 8 cents. Okay, well 8 cents, if we were to write that in money form, it would be 0.08. So anytime I see percent, I think of it in terms of money. How would we write it in money form? Well, that'd be 8 cents. Okay, so or think of it as like, if that would be 8 pennies. Okay, and in money form, we call 8 pennies 8 cents. Okay, so we'd call that 0.08. Think of it in like penny form. And then times the number of years, 5. And so doing the math here, 10,000 times 5 times 8%. Okay, well 10,000 times 5, I can multiply in any order, so now I have 50,000. When I multiply this and this. And then times 0.08. Okay. Okay, and that's going to be 50,000 times 8% is 4,000. And so our interest is $4,000. All right. And we've already done distance equals rate times time a bunch. But just really quick, a passenger plane made a trip to Las Vegas and back. On the trip, where it flew 432 miles per hour. On a return trip, it went 480 miles per hour. How long did the trip take if the return trip took 9 hours? Okay, so you're equaling D equals RT. Okay, and notice you're going the same distance there and back. All right, it's not like our distance changes. Okay, so this would be going there, and this one would be coming back. All right, so distance equals rate times time. We're going to have it twice here. All right, and so on the trip there, you flew a rate of 432 miles per hour. Remember, this is like your speed. Okay, and this is your time. Okay, and this is your distance. Remember, your rate is always going to be in terms of whatever two labels you have on speed and time. Okay, so if our rate is always going to be whatever our distance. So if we're going in terms of miles and our time is measured in terms of hours, our speed should be in miles divided by hours. Okay, and so we're looking at miles per hour here, 432 miles per hour. And so to think through this, we have 432, and we're trying to compare a trip there and a trip back. On the way back, our rate changes to 480. Okay, well, if the return trip took 9 hours, that becomes our time. We could figure out our distance here. Our distance is 480 times 9. Okay, well, 480 times 9 gives us a grand total of 480 times 10 minus a 480, but 4,320. That's our distance, and that's miles. Okay, well, if it's asking how long did it take to the return for the trip there, we're looking for this time right here. We don't know the time. So we're saying the distance is equal to 432 times time. Well, we know the distance now. Since the distance there and back are exactly the same, we can put 4320 in for distance here on the way there and solve this equation. So dividing by 432, divided by 432, just so happens this is easy division. You're left with 10. T equals 10. And that would be 10 hours, right? All right.